Hello everyone. So this is our final code for the supply chain management using Neo4j. So now I'll just quickly walk you through the code that powers our final submission, starting with the advanced data generator that builds a realistic graph, and then the advanced manager that analyzes, exports, and generates a report on it. So first let's talk about the advanced data generator. So let's talk about the first base class, that's the advanced generator. Here we use URI, user, and password. It basically initializes a Neo4j driver with configurable URI and credentials used for it, and it's kept outside the code path so I can just target the local or remote servers without any edits. Then we basically have a generate company name. Over here we create realistic company names by combining the curated prefixes and suffixes that helps for better analytical look. Then we have a generate smelter. Over here we build different smelter nodes which have rich attributes like country, risk level, capacity, certification, product type, and the output. This variety supports grouping and the analytics for the later part. Then we have the generate suppliers. Over here we build supplier nodes with material type, readability, reliability, and those different scores which have a certain amount of contract start dates, which is useful for like time awareness. And we basically generate a CSV report basing that relies on this time aware scenarios. Then we have the generate products. Over here we build product nodes with grade, price, and the minimum order value, useful for downstream aggregation, and it produces the relationships. Then we have several database operations that we do. First is basic operations, that's clear database. It's basically a hard reset. We run this before the regeneration to ensure that we have reproducible demos to show. Second is the create nodes. Over here, we basically bulk node creation. We unwind the list, create n label set items for like n number of items, and this is a fast idempotent per run and makes the data generation clean as well. Then we have the create supply relationships. Here we randomly connect suppliers and smelters via supplies, while realistic edge properties like volume and frequency. Uh, it intentionally allows us to create a Cartesian pattern for density that relies on indexes. Then we have the create production relationships. Over here, we same like it's basically the same thing as above. We randomly connect smelters with product via producers with a monthly output and quality score that gives us the numeric fields for the later reporting part. Then for the create partnership, here we add lateral smelter partners with smelters using different IDs in a range that ID S1 less than the ID S2 to avoid the duplicates, and the date and partnership type diversify the graph. Then we have the create indexes. Over here we create a range of indexes on a common lookup properties to speed up the match patterns and improve the demo responsiveness. Then we have a basic generate complete dataset part. Over here we orchestrate the full pipeline basically. So we have an optional wipe, a node creation, three relationship passes, index creation, and a summary, which is basically a single entry point where I can run for getting the analysis done. And then comes the main function, which basically generates a reproducible dataset and prints the simple next steps for the verification and in the Neo4j browser. Then let me walk you through the advanced manager. When we talk about advanced manager, first is a basic config class. Over here we just load and persist a JSON config. So the credentials, timeouts, and the database name are externalized, and it's versionable. Then when we talk about the different things in the class, we have a performance matrix. When we talk about it, this performance matrix is basically record, get summary, save report. So these three things are basically used for capturing per query timing and the different rows that are touched, and I call this for every other operation. So the get summary aggregates totals, averages, and the slowest query just for a small handy report. The save report is basically it dumps both the raw matrix and summary to a JSON, which is you know kindly more readable. And the record basically captures per query timing and the different rows that are touched for every query operation. Then we have a class called as the Neo4j Advanced Manager over here. In the init config, we basically bootstrap the driver from the config, which sets up a metrics collector and closes cleanly with no lead connections. Then we have an execute query. So the execute queries task is basically a single query wrapper which opens a session, runs the query, returns all the records, and always logs timing via the performance matrix, which centralizes and keeps the rest of the code clean. Then we use different inspection schemas, which is the get database info, then analyze the schema, and then we come to find disconnected nodes. So the get database info uh, basically returns a compact snapshot, counts like by label and counts by the relationship type and its property keys. I use this to print the on-screen summary, and the analyze schema basically shows me the constraints and the indexes which are wrapped in a try except block, so the report is resilient even if the feature isn't supported by this particular version of the Neo4j that we are using. Then we have a find disconnected nodes. This lists labels for like nodes that have no relationships in them, but it's useful to provide an evidence for the graph visibility improvements. Then we create different relationships. First is the create smart relationship. Over here, it's a generic pairing function. For example, connect smelters, by country or by risk level. So here we use ID N1 less than ID N2 to avoid the duplicates, as I told earlier, and it can be swapped with the element ID if we strictly need it. Then we have a create hub topology, which basically creates a central hub and connects all the nodes of label to it. And the create category hubs is basically to create one hub per distinct category value, for example, like one geography hub per country, and it links the members to their particular hub. This is basically a backbone for the community kind of visuals. Then we uh, basically have different graph algorithms that's used for analytics. The first is the calculate degree centrality, which computes the degree by counting incident relationships on a label, and it prints the top results as a quick proxy for the importance. The find shortest path, as the name suggests, returns the shortest path between any two nodes by internal ID, and it's simple and effective for resilience and questions. Then we have the detect communities. It's basically a lightweight connected component. We basically we used to group it based on a specified relationship type. It's sufficient to show the clusters without any GDS in it. Uh, then from all these functions, we basically have a data export, which basically dumps everything into a single labeled CSV with dynamic headers collected across all the nodes, good for just quickly inspecting the data in the spreadsheets. And then we create backup of it and delete all the relationships just to destructive helpers used during the testing, so I can log the counts to make the outcomes auditable. Then we basically combine all this to create the final report. Uh, so that's the code structure behind the final system, which is a generator to create a rich indexed graph and manager that connects, analyzes, and exports reports. So the improvements are visible, repeatable, and auditable. So now I'll just quickly run the demo for you as well. So here we go. First, let's just do a quick pip install from the requirements.txt. Then we will run the advanced data generator first. So as you can see, we have total of 100 nodes, total of 832 relationships. Then we will run the advanced data manager. Yeah, so we have all operations successful, and you can see this in the different JSON files that I told. It's the performance report.json. We have timestamp, query name, duration, and the records affected by it. We also have a report that is basically generated with an ID, the name, the state, the population percent, the type, entity type, and the labels or the types it supports. And then we basically have a complete understanding about how actually we want our structure to be visible and how performance wise we can upgrade from the traditional Neo4j usage. Hope you have all your doubts cleared for the project. If not, we have in detail readme file how you can quick start the project, how you can basically run, what URL you have to use, what's our database, what different codes do we have to run. The basically all the codes that I just mentioned are already in the readme file as well, for the same country, same risk level, geography, and risk hubs. Then you can see an in detail execution guide as well, and to understand the different code improvements that we did based on the submission that we did earlier, we have code improvements.md, which has a before and after section that we basically built to show that how we improved based on the previous submissions and how is the advancement of supply chain management using Neo4j actually taking into action. So now that we have seen the code architecture and the design improvements that I talked about in the Python implementation, let's just walk through the visual outputs generated by this updated Neo4j system. I'll explain how the final outputs reflect the enhancements over the initial submission. So let's just dive into it. So here's the first thing that I want to talk about. So this basically highlights how the graph has evolved. We now see three major types of relationships. First, the same country, a same risk level, and a hub-based relationship around the new nodes like geography hub, risk hub, and a central hub. So this, when I just zoom into it to just show you, I know it's a bit clustered. So let me just change the limit from 200 to, let's say, just 20. Okay, so as you can see it over here, this is what we call as a risk node. So these are the different smelters which have the company names. This is basically a central hub node, and this is our country node. So these were created dynamically using the smart relationship and the hub creation functions that I already talked about in the Neo4j Advanced Manager. Compared to the initial submission, this represents a major enrichment in the structure that improves the queryability and visualization. So as you can see, we have this gamma industry and global works, which are related by same country relationship, and the gamma industry, global works, everything is just linked basically to a central hub. These are connected to relationship which establishes a connection between a particular industry and its particular central hub. I'll deep dive into this relationship in the further demos as well. So now let's talk about uh, the new smart relationships. First, we have got a same country relationship. So over here, we form clusters of smelters which are grouped by the country. So as I talked about the global works, it has a smelter international foundry. So smelter 1 global works, smelter 2 international foundry. It's created by country Germany. Global Works has a smelter 2 Gamma Industries, which is also related by the same country, Germany. And basically, we have different smelters which are grouped by a same country. So this is what the query shows us. Similar to this, we have grouping based on same risk level as well. So this basically enables us to quickly, query the nodes based on shared attributes and enables higher level analytics such as community detection. So now that we know about grouping of different smelters, and its relationship types, now we can talk about hub nodes, which is basically a category based visualization. So over here we have a smelter Omega group which belongs to Australia. Omega Enterprises belongs to Australia. Similarly, Summit Foundry Mega Group belongs to Australia. And we have different smelters. We have different countries that are related to. So this basically, shows us that this hub topology is, fully automated, customizable, and something that was not part of our initial submission when we talk about it. And like I said, that we group a smelter based on the country. We can have it based on the risk level as well. So global works falls under a critical risk level category. Advanced metal falls under a critical risk category. So everything can basically be shown by this as well. Advanced metals, critical risk category. Global works, critical risk category. This is what we basically show from this query as well. Following this, we also have smelters that are grouped by a central hub, which I already showed down here that this is a central hub. It's a central hub for this Epstein enterprise, it's central hub for global works, it's central hub for gamma industries. So this everything is basically the same over here as well. Global works, Apex Metals, Absolent Works, we have a central hub for it. Then we have a query that shows top nodes that are based on the degree centrality. So we have different nodes, mechanical metals, meter processing, apex refining, we have an associated degree to it. This basically demonstrates that the graph analytics capability from this code that we are building is basically calculating the degree centrality to identify the most connected or the most influential nodes that are present in the graph. Again, this was not available in the previous versions. The analytic module is a part of the advanced manager and it adds depth to the graphic designs that we want to show. Then we talk about a relatively small thing but yet very very important thing, which is a disconnected node. This is basically a quality check. So it confirms the absence of a disconnected or an orphaned node that is present in our overall graph structure. Here we basically autofix this relationship and the hub generation, and this assures us that the final graph is well connected, so we can derive different kinds of relationships. We can establish which group they belong to, and This assures that the final graph has a key metric to validate and just makes a successful graph construction. So this was it for the final demo. If you have any doubts, you can always reach out to us in the discussion forum, and we are really ready to just help you out to solve all the doubts you have. Thank you so much.